All right, so today we're going to talk about 6.1, which is polygons. Now, a polygon is a multiple-sided figure, so it has 3 or more sides. Okay, so let's go over our names of polygons. What do we have? We have a 3-sided figure, which is a triangle. We have a 4-sided figure, which is a quadrilateral. Okay, if you don't know these, write them down. We have a 5-sided figure, which is a pentagon. We have a 6-sided figure, which is a hexagon. We have a 7-sided figure, which is a heptagon. We have an 8-sided figure, which is an octagon. We have a 9-sided figure, which is a nonagon. We have a 10-sided figure, which is a decagon. Okay? Above that, you might see 12-sided figures, dodecagon. Otherwise, they're just going to write it as, say, 15gon. Okay? So this number right here in front of gon would be your number of sides that the polygon has. Okay, now a regular polygon means all sides and angles are congruent, or they're exactly the same. So if one side's 5, all the sides are 5. If one angle's 60, all the angles are 60. Okay, polygons do work a little bit different. You don't have to necessarily have, it could be equilateral without being equiangular, okay? So to be a regular polygon, both of those things have to be true, okay? Now we also have convex versus concave. A convex is what you guys would normally picture as a polygon. That's where all of the sides are looking normal, okay? They all attach, nothing comes into the figure. Now a concave, technically the definition is if I extend each of these lines, do they go through the figure? However, I think of it as a cave. So if I have a polygon that has this indented part into it right here, this makes it concave. It's coming into the figure. Okay, now if you want the formal definition, if I extend all of these lines, see how I'm extending them? This line right here and this line right here are both going through the figure and they're intersecting other lines. That means it's concave. That means this one over here is convex. You just need to recognize those. The ones we're solving for are going to be convex. Okay, now we have interior and exterior angles, which is the part that we're going to learn about next. So for an interior angle, if I have my polygon here, lovely little thing. That didn't make a very pretty polygon, did it? Let's try that again. Okay, there we go. If I have a polygon here, my exterior angles, I'm going to have to extend my lines. My interior angles are exactly what they sound like. They're inside of the figure. So that would be this guy, this guy, this guy, this guy, this guy, this guy. They're inside the figure. The exterior, you're going to actually make your polygon look like a pinwheel. So instead of just having these sides, what we're going to do is we're going to extend each side in the same direction. So I'm going to start here. I'm going to get a different color. I'm going to start here and I'm going to extend it this way. Then I'm going to extend this one this way. Okay, I'm extending all of them clockwise. And I'm going to keep extending them as I hit every single side. Whoops, that one went down. Let's try that again. Oh my goodness. Okay, let's try that again. Go this way, and then this way. Okay, so my exterior angles, I'm going to make Y's. Here they are. These are all of the exterior angles. Okay, so the exterior angles, if it's a regular polygon, the exterior angles will also be congruent. The interior angles will all be congruent. The exterior angles will all be congruent. If it's not regular, they can be different things. And one other thing that you can notice is you can solve for the exterior angles 2 ways. I'm going to go over the second way in a little bit. The first way is if you have the inside angle, Notice these are on a straight line, which means they add to 180. Okay, so the y's are the exterior for this picture, and the x's are our interior angles for this picture. Okay, now let's start learning a little bit more about interior and exterior angles. So we're going to make this lovely table. If you need to pause the video to get it written down, go ahead and do that. And we're going to go through a couple examples and come up with a rule to find the sum of the interior angles. So number of sides, we're going to start with 3, we'll do 4, 5, and then we'll jump down to an n-gon. So that's going to be our rule. Okay, so for the first part, 3-sided figure, what's it called? It's called a triangle. Okay, now number of triangles, we're going to actually talk about drawing in diagonals. So when you just have a triangle, there's no diagonal to draw in, it's just a triangle. What's the sum of the interior angles? We've already done this. Every triangle adds to be 180. So there's our first one. Now our second one, 4-sided figure, what's it called? It's called a quadrilateral. Number of triangles, okay? I'm going to draw a quadrilateral over here. So here's my quadrilateral. Now what I'm going to do is I'm going to pick one vertex, so one corner, and I'm going to draw in as many diagonals as I can. For this one, there's only one diagonal we can draw in, which goes straight across. Okay, so we're splitting it up into how many triangles? 1, 2. So we have 2 triangles for this one, 1 triangle for a triangle. So what's the sum of the interior angles? Well, each triangle adds to be 180. So if my first triangle is 180, I have 180 plus 180, which is 360. Now let's do a 5-sided figure. A 5-sided figure is called a pentagon. So let's draw a pentagon. It doesn't have to be a regular pentagon. It can just be a 5-sided figure. It looks kind of like a house. Now we're going to draw in our diagonals. So I'm going to pick one vertex. I'll just pick the top one. It's easiest. And we're going to split this guy into triangles. So here's one diagonal. Here's my other diagonal. So how many triangles did we just make? 1, 2, 3. Okay, now each triangle adds to 180. So I have 180 plus 180 plus 180, which is 540. Okay, now let's come up with a rule. So an n-gon is going to be our rule. This is going to be an n-sided figure. Okay, there's no picture for it because it could be any side. And what do we notice? I notice a triangle has 3 sides, which makes one triangle getting to 180. I notice a quadrilateral has 4 sides. Number of triangles is 2. Then it adds to 360, or yeah, sum interior would be 360. Then I notice a 5-sided figure has 3 triangles and the sum of the interior is 540. So what's happening? To go from the number of sides to the number of triangles, what are we doing? We're taking the number of sides minus 2. Now how are we going from the number of triangles to the sum of the interior angles? 1 times 180 gives me 180. 2 times 180 gives me 360. 3 times 180 gives me 540, which means my rule, I'm going to take the number of sides minus 2 to get the number of triangles, and I'm going to multiply that by 180. You need to know that formula. That is very important. Okay, so this box right here, that equation, this equation right here gives you the sum of the interior angles of any polygon. You need to know that. N minus 2 times 180. Okay? Now, the sum of the exterior angles is always the same. Sum of the exterior angles is always 360 degrees. So now let's practice some. Okay, so number 1. Find each angle in a regular hexagon. And let's go ahead and do the interior, and we'll do each exterior just so we can practice it. Okay, so a hexagon. How many sides does a hexagon have? A hexagon has 6 sides. You need to know that. Okay, so if we have a 6-sided figure, if you need your visual, we can always draw it. 1, 2, 3, 4, 5, 6. Okay, now it's regular. What does regular mean? Regular means every single angle is exactly the same. So I'm going to call each one X. Okay, now if I want to find each of those, I'm going to add them all together like we used to. So we have 1, 2, 3, 4, 5, 6 X's. X plus X plus X plus X plus X plus X, which is 6X. What do we set that equal to? We added the inside, or we took the sum of the interior angles. Well, what in the world's the sum of a hexagon? I don't know, but I do know that we can find it with n minus 2 times 180. Well, how many sides does a hexagon have? 6. So I have 6 minus 2 times 180. We just came up with our lovely equation, okay? So 6x equals 6 minus 2 times 180. So first let's figure out what the sum of the interior angle is. 6 minus 2 is 4, and if I take 4 times 180, I get 720. And then you're solving. So divide by 6, and x is, let's see, 120. So every single interior angle is 120 degrees. Now exterior angles work the same way. If I draw out all my exterior angles, I'm going to extend all these lines. I'm going to go clockwise. So I have 1, 2, 3, 4, 5, 6. So I have 6 Y's, or 6 exterior angles, and I know that the sum of the exterior angles is 360. So I can divide by 6, and Y is 60. Okay, so that's for a regular figure. Any polygon, 4 sides, 6 sides, 8 sides, 10 sides, 25 sides, doesn't matter. That's finding each angle in a regular hexagon. Okay, some of your problems are just going to ask you to find the sum of the interior angle. So find the sum of the interior angles of a 14-gon. Okay, we'll go back to your equation. Our equation that we highlighted in green up here, n minus 2 times 180. That's the sum of the interior angles. So n minus 2 times 180. Well, what's n? N is how many sides the figure has. So that's going to be our 14. So we have 14 minus 2 times 180. Okay, so simplify that down. 14 minus 2 would be 12. And then we can take 12 times 180. And we know that all of those interior angles add to be 2,160 degrees. So that's the sum of all of the angles added together in a 14-sided figure. Okay, now sometimes you're going to see figures that do not necessarily, are not regular. So if we do one of those, let's do this guy. It made it look regular, didn't it? I won't make a pretty one. I'll make an ugly one just for you. Let's do this guy. All right. So let's say this is 3x, this is 25, this is x plus 41, and this is 2x. Okay, so all the angles are different, and that's fine. Okay, so we can still find the sum of them. So the sum of the angles that are already in there, I'm going to add all these together. So we have 3x plus x plus 41 plus 2x plus 25. Sometimes it helps to have a highlighter or a crayon, and as we kind of write them, 3x, okay, I did that one. X plus 41, okay, I did that one. 2x, did that one. 25, I did that one. So I have all my angles. Now, is this interior or exterior? This would be the sum of the interior. So we're going to use n minus 2 times 180. Well, how many sides does this guy have? We have 1, 2, 3, 4. So we have 4 minus 2 times 180. Okay, so let's put our x's together. 3x, 4x, 5, 6x, plus 41 plus 25 would be 66. 4 minus 2 is 2. 2 times 180 would be 360. And now we can solve. So let's solve down for x. Okay, so we have 360 on one side. I'm going to subtract my 66 over there to get 294. And then we can divide each side by 6. Oops. To get x equals 49. Now, that's just my x. If the problem asks you to find each side, what are we going to do with that number? We're going to take that 49 and we're going to plug it in. We have 3 times 49 for this angle. I have 49 plus 41 for this angle. I have 2 times 49 for this angle, and that angle is already 25. So then we can find each angle. So we have 3 times 49, which is 147. So this guy would be 147. We have, what's the next one? 41 plus 49, which gives us 90. And then we have 2 times 49, which gives us 98 for this angle. So if we added all of these guys together, 147, 25, 90, and 98, we would end up with 360 degrees. Okay, now you will see irregular figures that are also exterior angles. So if we give you this figure right here, okay, that is concave. Let's try that again. 1, 2, 3, 4, 6, 7, 8. So if you have this figure, sometimes you're going to have the exterior angles drawn in. Like this. And you might have some figures like this, some angles. We'll call that X. Call this X. We'll call this 10. Oh, forgot one. Okay, so for an exterior angle, you do the same thing. So the sum of the exterior angles means we add them all together. So I have 25 plus x minus 10 plus 2x plus 15. I would suggest not doing this in your head. Plus x. I lose track of my angles. Plus 2x plus x. So there's my 8 angles. Okay, oh, and plus 10, forgot. See, forgot one already. Equals what? Are these interior or exterior? These are exterior. So what do we know the sum of our exterior angles always add to be? 360. So now we can put all of our x's together. I have 1, 2, 3, 4, 5, 6, 7 x's. And then put all my numbers together. We have, let's see, I don't even know what I'm looking at. 25 minus 10 is 15, plus 15 is 30, plus 10 is 40, so plus 40 equals 360, and then we can solve. So we're going to add 40 to, or subtract 40 to each side. So we get 7x equals 320. And then we're going to divide by 7, and x comes out to be 45 point, I'm going to round to tenths, 0.7. Okay, and again, if it wanted you to find each angle, we would plug that back in for each angle. So when you're adding your interior angles together, you're using n minus 2 times 180. When you're adding your exterior angles together, you're always setting it equal to 360.